Alright guys, here's a quick video, at least at the start, for a reminder on graphing the sine and cosine curves. For both of these graphs, I will normally ask for at most 5 key points. Usually once we actually do a graph, I'll just ask you to label a relative max and a relative minimum on your graph, because hopefully they'll be right and then everything else will be right around them. But I will be looking at all the other points. So, like I said here, a quick reminder on graphing sine and cosine. I'm going to try to make this run super slow here. So on the right there, I wrote 5 key points, and I think the easiest way to get these points is our unit circle. So just putting out the quadrantal angles, I think those are the easiest points to get. So let that run pretty fast. But if you check out the graph at 0 degrees, I'll get my little highlighter over here. So 0 degrees, we have the point 1, 0. So the input on our graph is going to be the x-axis, which will be our radians, and the output would be the value for this graph of the sine curve, which is going to be our y value from the unit circle. So at 0, I've got 0, right, coming from our y value on here. So 0 radians, we're at 0 units. Or thinking of our opposite over adjacent, our y value, or opposite over hypotenuse, or the y value. So if I go up to 90 degrees, the sine value there is 1. So at pi over 2, I have 1 graphed on there. And then going through, right, all the others, 0, -1, back to 0, all the way around our unit circle corresponding to our graph here. It goes on forever in both directions. So I'll throw a couple more points on there. And again, labeling a couple of our key points. The ones that I didn't put in here are those angles in the middle. So for example, like pi over 6, the sine of pi over 6 is a half. So that's just another example of a point we can have on there. So as we spoke about in previous classes, the sine curve is a periodic function, meaning it will repeat at given intervals. So I've highlighted in yellow here one period of the sine function, right? I just re-highlighted it. So it goes from 0 to 2 pi before it would start repeating exactly one of those waves or cycles, whatever you want to call it. So that's the period of our graph, 2 pi. Another way to ask for that is frequency, which is just the reciprocal of a period. Or you can think about it as the number of cycles over some unit measure. So on this graph, our sine curve, we've got 1 cycle over 2 pi units of the graph. So that would be our frequency. Something else we might ask for, we might see, is called the amplitude, which is really from the middle of our graph, so our midline, to the max, or half of the distance from the min to the max. So on this graph, our amplitude would just be 1. Writing it in there. Something else we might get asked about the graphs. Our intercepts, since this graph does go on forever, right, we can kind of write out our intercepts in this pattern that we'll see. And something we used way back in chapter 1 was set builder notation. So we can do it like that. So the intercepts happen every pi units. So I can write pi n, 0 is like a coordinate, and then n could be any integer. So 0 pi, 1 pi, 2 pi, 3 pi, right? All of those are intercepts. Remember, I feel like maybe I'm talking fast, but thinking this is a review for most of us, feel free to pause, right? Fast forward, rewind, whatever you need to do. We can do the relative maxima the same way, right? So those would be all these max points on our graph. So here, here, all the way back here are all the relative maxima. And we can write that out also using our set builder notation. So the first one happens at pi over 2, and then every 2 pi units. So we could say 2 pi n, where n is an element of the integers. And of course our max there happens at 1 for the y values. All right, same deal for cosine, so I'm going to kind of just let this play out the way I graphed it, thinking about our x values this time on the unit circle, so 1, 0, -1, 0, right, happening at those same intervals. So we can see this starts at the max at 0, 1, and here's our 5 key points that most likely see from one period of the graph. All right, so that's a little reminder on our sine and cosine. These would be the parent function graphs. And I think in this video, we're getting kind of long, but again, you could stop, pause, whatever we need. I'm going to do the one graph, so I'm going to graph a sine curve with pretty much everything except for a period change. So I'll get my new graph queued up here. This goes along with our 4.4 worksheet. So we got a bunch of things going on here. The first thing we have is this negative out front, which is going to be a vertical reflection. Thinking back to chapter 1, for this our parent function would just be sine of x. So anything on the outside of the parentheses, right, of the argument of the sine function is going to be a vertical change. So we also have this 6, which is going to be, we talked about on that sine curve, the new amplitude of this graph. Then inside the parentheses, we've got a couple things going on. And the first is going to be a horizontal phase shift. So I wrote in general here, it's going to be this negative c over b, because if you see up in our like parent function up here, normally or sometimes we might have this b value that we would have to factor out. So if it is there, we'd have to factor it out dividing c by b to get what we call the phase shift, or just the horizontal shift. And last but not least, we've got that 2 on the end, which will be our new midline, or the vertical shift in our graph. So I like to start with the midline on the graph. I draw it in as a dotted line. And since it's at 2, and I had to take into account up here, we have a pretty big amplitude at 6. So I scaled my graph by 2s, otherwise I'm not going to be able to fit a graph 6 units tall on this grid. So kind of take that into account. And then for the regular sine function, right, we have our key points every pi over 2 units. And we should make sure we know those key points from the first graph, right? And I'm shifting pi over 2. So we have to think about what we want to label for our scale. So I'm going to do my scale by pi over 2. So I just picked like every 2 units, and I made that pi over 2. There are a lot of graphing methods for these, so if you have one that works for you, definitely go with it. I'm going to go over 2 right now. There are more out there, so if they don't work for you, talk to me or someone else and we'll find a method that works. But the first one I want to talk about is thinking about the sine function. So I'm going to draw a little mini sine curve over here. And it normally starts at 0. And then, like I said, we have all these key points at units of pi over 2. So that's important to think about to start. Also, we can see that the curve is kind of split into these 4 sections. So I highlighted the first one in yellow. There's a red section, a yellow section, and a red section that I highlighted there. So normally, the period of our graph is 2 pi, right? We can figure out what the new period is if it changes, right? And some good like units or a scale to make our graph by taking the period and dividing it by 4 to find out like our distance between the key points. So on this graph, my period's 2 pi, this guy that we're graphing here. So I'm going to take 2 pi and divide it by 4, and that'll be like a good scale. That's the distance between the key points. So we have to like take that into account when we're thinking about the scale. And for this one, since I'm shifting to the right pi over 2 scale would be great for this graph. So again, we'll talk about that more as the period changes on the graph, but just something to think about. So I'm going to put all of my pi over 2's on there, and then the first point I graphed right here by using my transformations. So I moved to the right pi over 2, right, I moved up 2, and that's my first key point. It's usually on 0, 0, so that vertical stretch didn't affect it, neither did the reflection. So I have that point, and then you have to think about all of your other changes. So normally my sine curve would go like up to the mountaintop first, and then come back down. Oh, gotta pause this, rewind a little bit here. Right, so I had that up to the mountaintop and back down. But now, since we have this reflection in there, I'm going to go, oh, let's see if I can catch some of this. I think I erased it by accident. I'll let it happen here. So I've got my points in there. Get my regular pen back. So here's where I'm starting, right at that guy. Instead of going up, I'm going to go down and I'm going to use the amplitude to figure out how low it goes. So I'm going 6 units below my midline. And then I'm going back up to my midline. We always start at the midline, go down to our max or min, go up to our max, and then again, every 2 pi is where I'm putting these key points. So back down to the midline. And you could keep going on forever, right? These graphs go on forever. I like to usually end at a min or max and kind of turn around. So maybe I'll do one more over here. Right? Not quite 2 full periods, but we can see the pattern there fine. So that'd be the first method, thinking about your horizontal shift and the distance between the key points on your graph, and using that to just kind of find a pattern and graph your points. So the second method would be kind of using, like we did in chapter 1, our transformations from the equation. So from my equation, I've got the changes to the x would be x plus pi over 2. And then the changes to the y are that -6 out front and the plus 2 in back. So -6y plus 2. Remember, all of our horizontal changes are the inverse operations. So even though I'm subtracting over here, I'm adding to my x values. Now, I really wouldn't take the time and go through all 5 key points with this. So I just like to do the first 2 key points from your graph. So I've got 0, 0, and pi over 2, 1. And I'm going to make all those changes I have up there to those points and put them on my graph. All right. When we're doing this method, we can pretty much see the scale. So I need to be able to pick out pi over 2, and I need to be able to pick out pi. So it really tells me what to scale my graph by. Let's got all our stuff on there. Once you graph your first 2 points, so I graphed those 2, then I just keep that pattern going on the graph. So every 2 units on my graph, I had a key point. So I go 2 more units, and then back to the midline. 2 more units, back to the max. So we have to know that our sine curve is going to go from the midline to the maxes and mins, like up and down. So you really need to have an idea of what the parent function looks like when you're graphing this. All right, I'm going to let it play out, graph it, and we are all set there. You can always check points at the end by subbing them in the equation. Make sure you could pick out key points on your graph. So like I said before, I'd probably ask for relative max and min. So an example would be, this would be pi, I scaled by 2, so -4 would be one key point. And then another one over here would be like 2 pi and 8. All right. So an example of a graph with almost all of our transformations. So you guys could try out the next cosine graph, and then I'll do maybe a quick video on how to graph that one next.